Hello. Hey, success. Okay, I'll stand still and avoid my temptation to wander around the stage all day. So, my name's M.Tamlyn. I'm a Django core developer, and I'm going to talk to you today about the ORM. I think if you asked a substantial proportion of the core team what their level of confidence of understanding of how the ORM works is, most of us pretty much consider there to be dragons there and don't have a clue what happens. Until about 2 months ago, I would include myself in that category. And I didn't really know what was going on, and this seemed like a good idea to try and find out what happens and understand what's going on. So what is the ORM? It's a bit of Django that most of you probably use every day. It maps Python objects to an underlying relational data store and allows for powerful expressions to interact with that. So we get to write some nice code, model.objects.filter, some conditions.selectRelated, .order by, nice Python code, and we get some SQL happens in the database, and we get it back. I personally have definitely written a load of ORM queries that have generated SQL I would have had no idea how to write. And I don't think I'm alone in that. In fact, I know some very good Django developers who struggle to write select star from table. This is just shows how good the ORM is, but it would be kind of nice to understand how it actually goes about doing what it does. Obviously, the answer to this is magic. The alternative explanation is Malcolm Tredenick was a very clever man and he wrote some very clever code and we don't touch it. Thankfully, it's not quite that bad. So I'm going to take you on a little adventure through a fairly simple use case, and we're going to see what actually happens when you write and run code that you would completely understand what it's going to do. So let's suppose we've got a model. It's going to be a dragon model. It's got a name. It's got a Boolean field that says whether it's trained or not, and it's got a foreign key to some other model called trainer. Nice, simple model, nothing particularly clever going on here. And we're going to run the query dragon.objects.filter trained equals false. So we're going to get all the untrained dragons, our friend Toothless here from the movies. So we know that we're going to get back some sort of list of objects here. We're going to get a query set. This is things you learn in the tutorial. But how do we actually get that query set, and what does it really look like? So I'm going to build up here on the left a list of classes that we encounter as we go along, and on the right a sort of pseudo-call graph where we're putting the methods and the initialization of these various objects as we go through, and we see what actually happens when we run that code. Query set equals dragon.objects.filter trained equals false. Well, the first thing we've got is a model. That's good. Hopefully everybody knows what a model is. It represents a class of objects in the real world, and it sort of corresponds normally to a single table in the database, and it houses logic about what those objects do. That's quite easy. They've got an attribute called objects by default. That's a manager. Something else that you might have written yourself, a subclass of manager, but you probably don't need to very often. We know what managers do. They're basically the place that all of our queries start. As I was discussing with Baptiste yesterday, what is the purpose of manager? The purpose of manager is to call getQuerySet. That's basically all it does. And we're going to call the filter method on this manager. So we've got model.manager.filter, dragon.objects.filter. That's where we start. This is a nice, simple method that we know what it does. And as I said, what's the purpose of manager? It's to call getQuerySet. That's basically what, if you look at the Django source code before 1.7, possibly before 1.6, you will see that the definition of manager contained a whole load of methods, def filter, def exclude, def order by, that basically just did self.getQuerySet.orderBy, self.getQuerySet.filter. This resulted in about 200 lines of very repetitive code, which in Django 1.7 has got better. And manager is actually built directly from a query set. So if you've ever written custom query set logic, you can now automatically get a manager that has that using the class method Queryset.asManager. And in fact, that's how the built-in manager is created. So what's a query set? Well, hopefully you got a passing familiar with what they are. Their purpose is to know about a set of objects and the underlying query that creates them. Okay, the underlying query that gets them out of the database. It's specific to this particular query that we're creating. And if you've got some situation where you have got multiple calls, you know, you've got a long chain of filters and order bys and excludes and limits and all the rest of it, every time one of those steps applies, it clones the query set, creates a new one, applies what it's already got, and then gives you the extra condition as well. So we're going to call Queryset.filter. Queryset.filter is one line of code, which is Queryset._filter or exclude false, negated equals false, and then the rest of the arguments that we've passed in. So that's quite simple. Filter or exclude is going to actually have to do something. We're now into our first thing, which is not in the documentation. So I said before, the query set knows about the underlying query that represents that it's going to run that will load in these objects. So it does that by having an attribute on it called query, which is an instance of query. There's a lot of Q's in this talk. So this query object models, is a model of some SQL. It's a model of the question that we're asking the database. It again is unique to the query set. It's created, in fact, in the init of the query set. So if we Queryset.filter or exclude is going to understand trained equals false, and it needs to tell, so we're going to modify its query. It's going to tell the query about this condition. Now it does that internally, always using a Q object. Q objects are something you may have used. They are documented, and they allow you to build more complex filter arguments, and you can just pass them in to filter. So basically what this does is it says, well, you passed me trained equals false to filter. I'm going to make that Q of trained equals false, and then just work with that object from now on. Represents a single condition in a filter or an exclude query. And we're going to tell our query, our underlying query, to add Q. So please add this condition to yourself. Again, this is actually one of those things where it's split into two methods. For those of you who know some SQL and have written some complex SQL, you'll know that sometimes you write it in a where clause, and sometimes it becomes in a having clause when you've got a group by. The purpose of the main method addQ, the publicly defined one, is to work out whether it needs to go in the where clause or the having clause, and then call _addQ having told it that answer. _addQ is going to actually do the work. So queries need to know about where clauses and having clauses, and we're going to be a where clause here because it's a nice, simple SQL statement. So we have a where node. Now, where node is a tree-like object, so it can have children. And this is where we get turtles all the way down, because where nodes can have where nodes that have where nodes that have where nodes, and they basically collect together all their where nodes and add them together or all them together to build up a complex query. So this is available as query.where. It exists, and we instantiate it here because to begin with, our query doesn't have a where clause, but we now need one. So we're going to create a where node and set it as query.where. We're now going to build the filter from our Q object. So we're going to build, as it happens, we're actually going to build another where node, and then we're going to add it at the bottom. So we're going to build a filter using this Q object, get back some object, and we're going to add it to our query.where. So how do we go about actually building a filter? This is a method of query which you have probably never seen, but I can almost guarantee you that you've seen the error message it will raise. If you've got something where it's like, this is basically checks that the keyword argument that you passed in to filter makes sense. So if you mistype the name of your field, if you try to use a relation that doesn't exist, this will tell you off about it and give you a nice yellow error page. That's kind of its purpose, is this keyword argument valid? Do I need to do any joins and so on? This is the other half, is the value that you've passed in. Does that make any sense? And if, assuming that it does make sense, what do I need to do with it? So one of the interesting things that can happen when you're using like search forms and that kind of thing is you can get a query, or for that matter, get arguments. The get argument has come back as a string. You've got a string 27, which is your ID or something that you passed out of a regular expression, and you want to get by ID on this, so filter ID equals the string 27, and it will work. Now, the database will get confused if you give it a string, it expects a number. So at this point, we run through the dbprep method of our model, of our field rather, and check that, process the value that you've passed in to make sure it's of the correct type for the database to understand it. A lot of the time, you don't actually need to do anything there. We then need to work out whether we need any extra tables. So in this case, we don't. We're just looking at trained equals false. We're just looking at a simple exact match against one column on the table. The way that this is done, it's quite clever. I don't fully understand all the implementation details, and I don't intend to ever change them. But basically what it does is it goes, there's a load of, I need some other tables. Let's just join them all in, and then we'll tidy it up later, and then immediately goes and tidies it up in trim joins. So it sort of just keeps adding tables and then tidy it up to make sure that it's quite clever. It's all tidy. So we've now worked out that the question that we're asking the database is valid, and we worked out whether we need any other tables. We can now actually build this object that we're going to attach to our where node. The first thing we're going to need is to represent trained. So we're going to turn that into a column object, or a col object. And this basically takes one thing in its initializer, which is the actual instance of the field, trained, the Boolean field trained. So this gets an instance of Boolean field, and it knows about its name, so it knows that it's trained. Django actually has gone, when we've done solve lookup type, the keyword argument that we passed in is just the string trained. We've actually now interpreted that as trained _exact. So we've gone, well, you haven't told me what else to do with this, you just said equals, so I'm going to assume you mean an exact match. Reasonable assumption. So we now need to deal with _exact equals false. So we've got a column object that says it's trained, this is the field that we're looking at, and we need _exact equals false. We do this by calling the method query.buildLookup. That gets us back something that the local variable actually called constraint. And we're passing the column object that we've just created and the information _exact, the value false. And we get back an object that we're now going to add to our where node that represents this constraint. We then got that. We can pass that back up to from build filter, gets added, and we're all done. This is where things are actually different in Django 1.7 to they've been before. This is the Django 1.7 code. Previously, we would store some sort of interesting, tuple-related information or something in build lookup. We now actually create an instance of a class. It's called exact in this case, and it's a subclass of lookup. And that has a left-hand side, which is the column object, a right-hand side, which is false, and it knows that it's exact, so it knows that it's trying to do an equals in the database. So there we go. That's what happens when you do create a query set with a simple filter. Great. Hooray, we made a query set. So just to look at this properly, and have a look at what we've actually built here. And note, this is largely not public API. You do not want to go hacking around with these objects directly, but it's still interesting to see how they work. So, we've got a query set. We know what that is. It's got an attribute called query, which is the underlying query object. that models what we're going to do. That's what we've been working on with the whole time. That's got an attribute called where, which is the where node. Where nodes are tree-like objects. They've got children, and in this case, it's got one child, which is the lookup, the instance of exact. That's got a left-hand side, which is the column object, and a right-hand side, which is false. So that contains the information trained equals false. That's the query, and there's a bunch of other information on our query, some of which we've sort of touched on very briefly, but we haven't actually used, and other which we haven't used because the query is quite straightforward. So queries have got tables. It's just a list of strings that says which tables we need to interact with. In this case, it's just the one table, Dragon's Dragon. They've got an alias map that tells us about the join information. This is basically a dictionary where the key is the table name and the value is a named tuple, which contains information about how is this table joined. In this case, the value is actually none because it's not joined, it's where we're starting from. But if we were joining in another table, the information about how we join it in is in alias map. It's got another where node called having, which in this case is none because we're not doing a weird aggregation query, so we don't need to worry about it. It's got a thing called order by, which I think in this case is an empty list. It's got a thing called select that says, are we only selecting certain fields? For example, if we're using only or deferred or values. And it's got a low mark and a high mark, which is what will happen when you've got slices. This is basically going to correspond to limit and offset in your SQL. And we can print this query, and using the dialect of SQL known as the amount of syntax I could be bothered to type, we have some actual SQL. Excellent. That's good. We're selecting the name, the trainer, and the trainer ID from Dragon's Dragon, where trained equals false. Good. Hang on a minute. How did we get to that? We've modeled what this query looks like, but we don't have any Dragon objects yet. And where did that SQL statement come from? Obviously, the answer is magic. And in order to get magic, we need a wizard who's going to create this. And the wizard in this case is a chap called SQLCompiler. His purpose is to understand the query and to build a SQL string. So, we're back where we were before. If we wanted to get and now use this query set, loop through it, cast it to a list, what's going to happen is we're going to call Queryset.iterator. We're going to try to turn this query set into an iterator, and we're going to pull out some objects. That's going to ask the underlying compiler, the underlying query, to get a compiler for itself, which will create an instance of SQLCompiler. SQLCompiler will know about the query, and will then ask the SQLCompiler to execute its SQL. Okay? Actually, first we're going to ask it to iterate, to give us an iterable of its results. That's what we do. So we're going to we've said, query, get yourself a compiler, and then give me an iterable of the results, and I'll turn them into model objects for you. So the SQL compiler goes, okay, that's fine. Well, I'm going to need to execute some SQL to do this. And in order to execute some SQL, I better know what my SQL is. So we'll call my asSQL method. AsSQL basically looks like, let's build up a list of strings, join them together with space. So the first string we need is select. So thinking of that SQL that I had on the screen a minute ago, what we're going to create. Well, we've got select, and then we need a list of columns. So we'll call SQLCompiler.getColumns. That will inspect the query object that it knows about, and it will go, have we got any information in query.select? In this case, I said query.select is none, so it goes, okay, I'm pretty sure that doesn't mean you want no data, I'm pretty sure that means you want the default data, so I'll call default columns, get default columns, and I'll introspect the model using the model's meta, work out what all the columns on this, what all the fields on this table are, and give you that list. So we've now got select a bunch of things. We then need the from clause, so the string from, and then we're going to have call SQLCompiler.getFrom clause, Now, in this case, the from clause is really simple. It's just from dragon's dragon. But obviously, this is where all the joins come in. So this would inspect query.tables, it'll inspect query.aliasMap, and work out what the correct clause is using the inner joins, the left outer joins, whatever it is we need to do to get the query that we want. Finally, we've got our where condition. So we're going to have, does query.where exist? Yes, it does. Well, we'll put in where, and then we'll compile the where clause. As I said, this is kind of turtley. You've got lots of similar objects as you go down, and basically what we do is we do compile it. SQLCompiler.compile this object, and compile goes, okay, I'm going to call its asSQL method then, and then the next step down it goes. Compiler, what gets passed to asSQL is the compiler object, and then the compiler object in the where node, the asSQL method in the where node will go, okay, well I've got these things. I've only got one child, or if I've got multiple children, I'm going to join them together with ands, but I'm going to need to compile the things below, and we recursively call down, so we call the compiler, call exact.asSQL, which will go, well, I'm going to compile my left-hand side, my right-hand side's false, I don't have to do anything with that, I can just pass that straight to the database driver. And then, so the right-hand side was column, so I'm going to compile a column, that goes and looks at the field name and turns it into dragon's dragon.trained, and pulls that out. Obviously, in some situations, this would be a little bit more complex, but what we end up with here is the compiler, SQLCompiler.compile query.where is going to be dragon's dragon.trained equals false. And get back that string. We can now actually execute this query. We've got a complete SQL query. We've joined together all of those little bits and pieces with space. We've decided there's nothing else we need in this query, so we'll go and execute it. I could have, at this point, spoken about what happens when you run connection.cursor.execute, but basically, as far as I'm concerned, we send some SQL to a database driver, and it gives us back some data. And that's not actually very much code in Django at all. It's all in the database driver, and I didn't fancy reading the PsychoPG2 source code. And it's also going to be completely different depending on which database you're using. Suffice to say, we get back some data, and we yield that up our tree of iterators, and we then pass it into Dragon, and we create some Dragon objects. So this is what actually happens when we go and run it. We try and iterate through the query, SQLCompiler steps in, builds up the query one step at a time, joins it all together, we execute it against the database, and then we create some objects. And it works. Hooray, we get back toothless. So having done that, we can now think about how some more complex queries work. That's a really simple example, but we can go through what we can see now, what will happen under the hood when we do some more interesting queries. So here we've got trainer _is Viking equals true. So we're now looking at an attribute of a related model. We're looking through a foreign key and doing a filter there. So in order to build the SQL that was going to execute that, we're going to need to know about joining in the other table, and then we're going to have another exact clause in the same way as we had. So this will change query.tables. It will change query.aliasMap, and it will still have query.where, which will contain the same information. So that's quite straightforward. What about this one? Filter trainer in a list of trainers. Well, actually, let's pretend that trainers isn't a list of trainers. Let's pretend it's a query set of trainers. And it's a query set that we haven't executed. What will actually happen here is we'll end up with a subquery. So when we were processing the lookup value, which is one of the methods on query that we called when we're creating it, we'd actually go, hang on, this is a query, not, so when I come to compile it, I will need to compile that query and include it as a subquery, and that means that I need to be careful about what tables I've got, and I need to update the alias map to actually do aliasing, to alias the tables if necessary. The other thing that's going on here is we've got a different lookup. We've got _in rather than _exact. So instead of creating an instance of exact, we'll create an instance of in, which is also a subclass of lookup, and that knows that when it joins it together and creates some SQL, instead of using an equal sign, it uses in instead. Tell the database what to do. Well, this one. Standard simple database optimization. Let's select related in the trainer table at the same time, because we're going to want to print the information about the trainer and the dragon. This means that we now need to select more information. So we're going to tell query.select that we want all of the information from dragon and also all of the information from trainer. And we're going to update the alias map and tables to say that we want to join in the trainer table at the same time. There's no where node on this one because we haven't done any filtering yet. Let's order these dragons by their age. There wasn't an age field on the model, but close enough. This is going to check that age is something that we can order by, raise an error if it isn't, and then it's going to set that in onto query.orderBy. The exact details of how it goes about doing that aren't necessarily very interesting, but that's what it does. And then when SQLCompiler comes to compile that query, after it had checked to see whether there was a where node, it checked, is there anything on order by? And the answer was no in the before, now the answer is yes, so it will compile the order by using SQLCompiler.orderBy, I think, or order by clause, and we'll turn that into a string to pass to the database. We've also got slicing. This will set high mark to be 3, and I think either not set low mark or set low mark to be 0. I think it sets low mark to be 0. After SQLCompiler has checked whether there's an order by to do, it will then check, do I need to do a limit and an offset? Check high mark and low mark, update the query appropriately, off we go. Distinct, again, this just goes in a different place. It should now be select distinct, or if we're using a proper database Postgres, select distinct on some fields if we want to do that. That gets stored, I think, in query.distinct, which will get inspected after the select, but before the tables. Values. Values doesn't give us back dragon objects, it just gives us the data. And it only gives us the data for the fields that we're asking about. So this will actually give us a values query set rather than a query set, which basically just does something different on the last line of the second graph I had up. Instead of instantiating dragon, it just returns some data. Everything else is actually the same. A values query set has the same underlying query. In this case, it's going to know only about certain things, so it's going to have query.select set to only be the things that I want to pull out of the database. But other than that, it will do the same thing. In fact, if I don't pass anything like I haven't here to values, it will select. It will still have the select attribute set to none, get all the default columns, and return you them as a dictionary. Prefetch related. This is select related's friend. For those of you who know that's how this works, you will realize that this has got absolutely nothing to do with query. Because we don't actually run one query when we do a prefetch related, we run multiple queries, one for everything that you pass to prefetch related. So all of this logic to make prefetch related work happens at the query set level. And it will go and run the first query, and then it will run the prefetch query where it's loading in the related objects. And those two separate queries, the first one, simple query like we had, the second one will have a double underscore in, a load of IDs, which are the IDs of the objects that we loaded in the first query. So that's pretty good. I think we've now got a reasonable understanding of how most obvious select queries are going to, most obvious read operations are going to work. Chances are you probably want to do more with your database and just read data from it. You also want to create objects, you want to update objects, you want to delete objects. So how do they work? Well, there are a number of subclasses of query and corresponding subclasses of SQLCompiler. There's a create query, there's an update query, there's a delete query. Create SQLCompiler, update SQLCompiler. Quite simple. The manager will go and create one of these. The other place where they get created directly is instance.save, which is the only query that doesn't initiate in your manager most of the time. And we can go and create the relevant queries using this, and they will compile using their own versions of SQLCompiler that instead of starting the statement with select, will start with create or update or delete. There are two other main subclasses of query in SQLCompiler in the Django source code. The first one of these is one that deals with aggregates, so select .count at the end. And the second one is one that deals with dates. So when you do queryset.dates, which returns you just a list of date objects, it's a different kind of query set, but it's also a different kind of query that you're asking the database to do, and it's compiled a little bit differently. But everything starts with the select ones, and then it adds and removes features from the select query as necessary. That's basically how the ORM works. There's a couple of other things, sort of tangential things I'm going to talk about, and some changes that might be coming. So the first thing is we didn't talk at all here about database agnosticism. We didn't mention a database, but the SQL, I sort of briefly mentioned it when I said that this dialect of SQL that I put up was the amount of stuff I could be bothered to type. But for those of you who interact with your databases directly occasionally, you'll know that you need subtle differences in what the database will interpret, depending on whether you've got MySQL or Postgres or Oracle or SQLite. How do I interpret the value false and pass that into the database? That actually depends on the database in question. Now, because the database drivers are quite good, we don't actually have to worry about that one, but we do have to worry about how we're quoting the names, for example. Do we need single quotes? Do we need double quotes? Do we need quotes at all? Depends on the database. So a database backend, which you choose in your settings, comprises about 5 different things, only one of which we're interested in here, which is the first one, database operations. This is, the instance of database operations is available on the connection object as connection.ops. You can have a look at it. It's basically got about 35 different methods on it that do various little things where the databases behave with their own subtle little quirks. We've also got a thing called database features, which is basically a list of Boolean flags. It's like, does the database behave like this? Does it not? This is mostly used in creating classes, and there's a couple of other places. We've got introspection, which is needed when you're doing migrations. We've got validation, which checks whether we're doing the right thing. Have you tried to create an index on a car field on MySQL where the car field's length is more than however many characters it is that MySQL will give up? And we've got a client object that tells us how we're actually going to interact with, how do I get a cursor? What Python module do I use to go and execute my query against? But the only one that we actually care about for this purpose is database operations, which is used by the SQLCompiler in a number of places. So in all of those methods that the SQLCompiler was going through, if we drill down into what actually happens when it does from clause, in certain places it will do connection.ops something to make sure that it's doing it in the right way for that database. The SQLCompiler, that's the first point that we actually get any difference between the databases. The first graph that I had up when we're creating the Queryset object, that's got nothing to do with the database at all. It's only when we come to compile it down to a SQL string. So let's talk about some shiny new things. In Django 1.7, which will get released eventually, promise, there are custom prefetches. So for those of you who haven't seen this, it basically allows us to, prefetch related allows you to select a many-to-many or a reverse foreign key in and get them all in a database efficient manner. But you can only get all. You can't get filtered by a certain thing. You can't select related anything onto those objects, whatever. This allows us to customize the way that prefetch related works to support an arbitrary query set. So we can write code like this. The first line, prefetch related prefetch dragon set, is actually exactly the same as if I didn't write prefetch, I just wrote the string dragon set. The second one, we're filtering it to only the trained dragons. So we can pass in a query set object, and we'll only load those objects out the database. We can let the database do that work for us, and we can still use prefetch related to make it more efficient. What we should be doing in that second case is what I've done in the third one, which is using toAttra, because otherwise it puts only the trained dragons on dragonset.all, which is a bit confusing. Or the untrained dragons, rather, on Queryset.all, which is a bit confusing. So I would actually, if I was writing that second line of code well, I would write toAttra equals untrained dragons, which would save those dragons as a list onto my trainer object as under the attribute untrained dragons. Very powerful. Basically means that you shouldn't ever have to be doing crazy things, looping through and filtering, looping through and some sort of unpleasant code in order to make sure that your database interactions are efficient. Custom lookups. These are also new in 1.7. Unless I'm spending quite a bit of time writing custom lookups with contrib.postgres, but you probably don't need to write them very often. They know how to the change to what happened from before is that previously they would just say, I'm an exact lookup, and SQLCompiler would look up in a table, what does an exact lookup look like, what does it look like for this particular database, and turn it into a string. The responsibility for that has been passed into the lookup objects themselves, like we did have with where nodes before. So they know how to do it themselves, and they're defining, we've actually now got documented definition of what we're calling the query expression API, which is that these objects have a method called asSQL, which knows how to compile itself into a SQL string. They have as vendor name, where vendor name would, so if you needed to do something different for MySQL, you would implement as underscore MySQL. It's the name of the database, not the name of the database backend. And they also have an output type that says what we can do with this object afterwards. Do we get back something that looks like an integer field? Do we get back something that looks like a car field? And the output type should generally be an instance of a field. Really hypothetically, we've got possible things in Django 1.8. There's been some discussion on Django Dev recently about sort of extending the way that these expressions and things work. So creating expression objects. We've kind of got expression object at the moment in that we've got f. So you can have f of a field, and you can have f of a field plus 1. And you can use that in updates, and they kind of work quite nicely. But you can't use them to do complex aggregation. So I can't get the sum of field A plus field B for all of my tables. That would be nice to be able to do. They're not always necessarily the most efficient queries, but they're definitely more efficient than loading all of the objects and doing it in Python. So it came out of that ideal of being able to do more complex things for aggregates, but the implementation that we're coming up with and we're starting to settle on is flexible enough that we should be able to use it in order by. That's what a recent Django Dev discussion was about. So we should be able to order by this particular expression that we've defined in our SQL. We should be able to use it in values queries, values list queries, and once I've finished all of the rest of the Postgres specific stuff, one of the things that's coming is custom indexes. So we'll be able to also define an index that's a functional based index based on a particular expression. And these objects share the query expression API that we had before, so they can be monkey patched to support third-party databases. You can create a third-party implementation and it will work and Django will understand it. It doesn't rely on an internal lookup table. So hopefully you understand a little bit more how the ORM works now and how a query is built and executed. And I'll give you a little bit of a guided tour of some of the things that might be changing. Does anyone have any questions?
Thank you very much. The call tree you showed in the first part is pretty long, pretty extended. So I wonder if there are some performance issues about it due to this length.
You'd have to ask Ansi about the performance rather than me, to be honest. This one. Yeah, I suppose all of that pretty much is just doing a single pass to filter. And obviously addQ gets pulled multiple times if you pass multiple arguments in. We need to build a tree to represent this properly, and building trees tends to result in some recursive code. There are a bunch of methods that are called here. There are actually a lot more methods that are called in the other graph that I didn't write down. All of this, there's the Django bench project that Ansi looks after, who's one of the other core developers, and whenever changes are made to this, they are benchmarked, and if there's anything that looks like it's going to make it slower, then it does. This is all done at Queryset creation time, and it's a bunch of function calls, but it's not something that you're going to do inside a massive loop, hopefully. You don't tend to want to create 300 query sets in the course of a query. We're talking about milliseconds, not about, we might, if we improve it by 1%, then your average website is going to, respond half a millisecond faster 10% of the time. So it's not a huge gain, but obviously we do keep a close eye on this to make sure that we don't make the performance worse. I think there was a small performance hit by the change to lookups, but again, it was a couple of percent, not anything that significant, and the extra power that we got from the improved API made it worth the offset.
Thank you.
Questions?
I bewildered you all, obviously.
I know maybe this is a bit specific to one type of database, which is Postgres.
Yep.
Usually when...
Sorry, that's the right database to be specific to.
I know. Usually when you have to save, search, or delete something using the ORM, you get the table name from the getQuerySet method, or the manager gets the table name, which is the same for all kind of operation. We faced, where I work, we face the situation when we have inherited tables and we have to use one table name for searching and another table name for saving or altering data, so save and delete. Because you know inheritance in a Postgres table. You search on the base table, the planner goes down to the correct inherited table, but when you have to insert or alter data, you have to go straight to the inherited table, child table.
Yeah.
So we managed to write custom SQLCompiler and query and modify the ORM, but we don't know, let's say it's more a homemade solution, it's not so clean. Yeah. So I was wondering if in 1.7 or 1.8 there will be some kind of support to have separate tables for reading and for save and delete methods.
Although I use Postgres, I don't use it in any sort of scale very often, so I'm not particularly familiar with the performance-related stuff. The first thing is it definitely won't happen in 1.7. It'll just be feature frozen for months. If it does happen in 1.8, it would be likely to be because someone's written it, possibly you. There's no plans I know of to do anything like that. I think possibly you're in an interesting sort of situation. I'm not sure why you're needing that behavior exactly. Maybe we need to talk about it afterwards. Certainly if it's for scaling purposes, it tends to be better to have database replication, and then we've got an infrastructure for doing that, for directing reads to one database and loads to the other database. I don't know whether the router mechanism could actually change the table. I need to check what the docs for router are. I don't know whether you'd be able to do it there. Potentially that's where the correct hook would be, to allow SQLCompiler to use the router to work out what the table name is, depending on whether it's a read or a write operation. That would be my guess, rather than having to change things too much. Basically allow router to do routing within a single database rather than just routing to different databases. Don't know. Any other questions? I don't know.
Thank you, Mark, for peeling back the layers with such clarity. Now, having seen what's going on underneath there, I wonder if
you're supposed to care.
So you wonder if?
You wonder if you're supposed to care.
Well, rather the contrary, I wonder if there's a temptation, a danger that people will be led into the temptation of diving into that when they should not be trying to do that, because you see quite a lot of this where people try and shortcut problems they're having by going under the hood of Django operations when they ought to find a way that is actually on the surface and not underneath.
Most of the methods that I put up there are, like I sort of explained in 1 or 2 sentences what they do. Some of those methods, like _add_q, is about 15 lines of code with a bunch of if statements and edge cases. There are a lot of edge cases in the ORM. It's not I've distilled it down into something that's understandable, and there's lots of edge. I don't think anybody understands all of the edge cases. This is why we have a test suite, to make sure that it still does the right thing. And those edge cases aren't necessarily database specific. There's an object that I didn't put up there called join promoter, which is the thing that handles how we add in joins and take them down and work out what sort of join we should have and so on. And it's a complex piece of logic. I don't think there's really any reason to change, to use these APIs directly. It's kind of interesting to know how it works, but if you're having a problem with it, it's a bug and you want to tell us that, rather than dig underneath it. The only reason why it would be interesting to know how this works in order to play with it is if you wanted to do a different kind of query. So like, for example, aggregation or dates. If you wanted to do a kind of query that is not standard, let's suppose you wanted to do something where you wanted to build a system where you join something against an introspection table or something, and you're doing something you probably shouldn't be doing with your database that's not a simple operation, then Query and SQLCompiler will give you the tools for how Django normally does that. But I wouldn't go messing with them directly. It's just quite nice to see how they work. Any more questions?
We've run out of time for questions.
Okay.
So thank you, Mark.
Thank you very much.